idea now is to prove the endpoints formula step by step. If you see this slide, the whole deal, then it looks complicated. But don't get scared by it. It could have been use a fancier software, and press and then just show that first, and so no problem. Then show the next line, then piece of cake, right? So everything is so easy. So don't scan, look at the whole deal as yet. So line by line, right? So this is a particular titration, complete reaction at equilibrium. Okay, so let's assign some number. So this is the concentration and the volume added, and this is the concentration and the volume added. So notice they are equal number of moles, right? MV, then sure they are equal. So this now is at the end point, right? So the condition is at the end point. So the two mix is going to generate your product, 0.1 molar, right? So MV should be 0.2, but then dilution over 20. So now you get a 0.1 molar concentration as product. So is that. Now this is product at equilibrium. So you're going to take care of the reverse arrow at equilibrium. So it's going to the 0.1 minus x, go back. Okay, same here, minus x, go back. And generate, that was a 0, and now generate a little bit of x and an x there. Okay, so that is the condition at equilibrium, chemically speaking. Any question with that? Now, the potential. Keep in mind, this is one solution, right? It's one mixture. So the potential there, this potential is same as this potential. They are the same mixture. So if we calculate the potential based on cerium chemical in the mixture, it's equal to this, right? So now it's at equilibrium, right? So it's 0.1 over x, right? So the two cerium species. Okay, the potential may be calculated based on the iron species as well. So the Nernst equation follow. Then it's going to be x over 0.1, for the particular species of the two. So x over the 0.1. The minus x is negligible. Minus x because the k is large. The forward reaction is large. So any problem with the Nernst equation? The two?
Can you explain, you probably already said it, why the first one's flipped? Why is it 0.1 over x?
Okay, notice this is 0.1, right? For cerium, this is 0.1, no problem to get the product, right? And this is x, right, at equilibrium. So now the 0.1 is cerium 3 plus over cerium 4 plus.
But why in the iron is it flipped? Why is it x over 0.1?
Right. It's always reduction and oxidation.
Yeah. Yeah. Okay. So up to here, though, don't get confused with the below. Then y is a plus later on. Okay. So now the next step is just algebra. Remember, when you see an x here, you try to get rid of it. How do you do it? Then it depends on the arrangement. So now you say that, okay. If you put a plus in front here, then this is going to flip upside down. Then once it flips upside down, then you're seeing the same thing, except the plus is changed. So that's what it is. Okay, so the top one stay, that's what it is. We simply move the NCE to the left. Okay, multiply that, so every quantity is going to be multiplied by NCE. So we'll end up with that. So this multiplied by NCE, and this is multiplied NCE, that's multiplied by NCE. So you end up with that. Then the bottom one, similarly, except you put a plus in front. So that flip upside down. So now we're looking at this equal to that, right? So you add up the two, then the picture of the x will go away. So this is algebra, right? So once that is gone, then you end up with the remaining things. So it's going to be equal like that, remaining thing. So now you extract the E, the potential, then you equal to this. So this is your formula, right? The A, B, number of electron. Okay, so this is your formula for equivalence point calculation. Any question with that, Nassim? You seem to be puzzled.
So we can just use the body equation, right?
Right. It's proven. Okay, now for some people, then they may say that, I am different. I like to use the little x. I go the knowledgeable way rather than the easier way. Like Jeffrey, right? Jeffrey said, okay, yeah, you all do go the easy way, I go the hard way. Just kidding with you, we are friends, so friends don't mind sitting around. Sometimes I need to sit down with you to talk philosophy. I still try to understand the book you gave me. Just one sentence takes me so long to understand. Jeffrey gave me that little book, really thin. Oh, good, I can finish it in a day. But then, reading one paragraph, oh boy, that is so, one can say sentences contradicting, yet they are connected.
Number 3, a thought as a proposition with the saints.
That one. Yeah. Thanks for sharing with that. That's a good book. Okay, so let's say that I go with the hard way. It's still okay, get the small x from the k, then you should end up with the same answer. So get the k first, though. You calculate based on the k, equilibrium k. So remember this formula I asked you to memorize for. Okay, get the particular k corresponding to the two chemicals. So now you plug in like that, and you get the k. The magnitude, indeed, is very high. So you're going to expect the x to be very small, right? 10 to the 14. So now come back to example, but let's look at different quantities here to confuse you a little bit. But no big deal, it's MV. Question?
What is the 0.059?
Where?
Oh, it's a constant. Okay.
Don't ask me where the 1 comes from. If I added a 1. Oh. 10591. I am confused now. Where's the 1? Okay, so here is what you added, your titrate, okay, add to, let's say, this chemical. So you get the MV, right, MV. So now, what do you think? Is it before the endpoint or after the endpoint or at the endpoint?
After.
No, this is your analyte.
Oh.
Huh?
I thought you asked me questions.
Yeah, so right, so this is obviously before the endpoint, right? Okay. So before the endpoint, if you go the easy way, then you're going to base on the iron, right? The iron is before the endpoint that we did previously. But Jeffrey say that, okay, I use the X here, I go the hard way, so I base on theorem instead, okay? So based on the theorem 1, that this is the Nernst equation 4, but then you will need to know the X. Now where's the 0.5 come from, right? The 0.5 is the 3+ generated based on this quantity, right? So this is all going to be reacted, okay? MV is equal to 0.5. So whatever left behind is virtually 0, but it's at X. So this is whatever this is going to be calculated for. Okay, so the K is equilibrium constant by definition, product over reactant. So your product, okay? So 0.1 generate. When this is 1, this is 1. When this is 0.5, this is also 0.5, right? 0.5, 0.5. So 0.5, 0.5 for products. Then the theorem 4+ is X. The Fe2+ is going to be the difference between the two, whatever that is remain. Okay, so 0.5 become that, so left behind 1.5 minus 0.5 is equal to 1, right? So that is equal to 1. Any problem with that? Okay, so the K is equal to this magnitude, right? We just calculated it. K is equal to that. So X is really small, 10 to the minus 15. Okay, so now you can plug in and calculate. So now log 0.5, the Nernst equation, 0.5, X is this number. Then you end up with the same, end up with this value, 0.75 volt. Okay, this is 10 to the minus 15. So you may say that, let me guess, how can you get this number? This is 10 to the minus 15. Do this exercise at home. So prove your math, your math skill. Okay? This log scale. So this is pretty interesting, right? Even though you have such a tiny number, you end up with this, the same value that you calculate based on the iron.